Let's take a look at some compositions that involve sine and inverse sine. When we look at compositions, we need to look at the outside function first. So in this case, the outside function is inverse sine. And when we think about inverse trig functions, we should be thinking about angles that are restricted to a certain part of the unit circle. And we should know that inverse sine is an angle restricted to the right side of the unit circle. So that is, the value for inverse sine is an angle from minus pi over 2 to pi over 2. Remember that that means we must stay in this interval from minus pi over 2 to pi over 2. We can't come around counterclockwise. So if we're in this position right here, that's minus pi over 3. That is not 5 pi over 3. Okay, so if we're talking about the value of inverse sine, right down here, that's minus pi over 3, not 5 pi over 3. Okay, so when we look at this, it's very tempting to want to cancel out inverse sine and sine because they're inverse functions of each other. But again, what we have to remember is that the value here for our final answer has to be in the range of inverse sine. 5 pi over 6 is over here. That is not in the range of inverse sine. So we know the answer cannot be 5 pi over 6. So we have a couple of choices. The simplest, most straightforward way is to just start on the inside and work your way out. So this would be inverse sine. We go to 5 pi over 6. That's right here on the unit circle, 5 pi over 6. The sine value at 5 pi over 6 is the second coordinate, so that's 1/2. And now we move to the outside function, inverse sine of 1/2. That means the angle on the right that has a sine value of positive 1/2. That angle is pi over 6. Let's try another one. Inverse sine of pi over 3. Here we see that pi over 3 actually is in the range of inverse sine. So we should suspect that we can, with this case, cancel out the inverse sine and the sine. But let's be safe. Let's rewrite this. Let's start from the inside. Sine of pi over 3 is the second coordinate at pi over 3, which is root 3 over 2. And then inverse sine of root 3 over 2. That's the angle on the right. That has a sine value of root 3 over 2. So it's an angle on the right where the y coordinate is root 3 over 2. Sure enough, that's pi over 3. Let's try another one where the composition is reversed. So when the inverse trig function's on the inside and the regular trig function's on the outside, what we will see is that in these two cases, these two examples, so in the case where the trig function's outside and its inverse is inside, here we will always get cancellation. So let's check it out. Let's just be safe though. This is going to be equal to the sine of inverse sine of negative 1/2. Angle on the right with a sine value of negative 1/2. That's minus pi over 6. Sine of minus pi over 6 is negative 1/2. And this will be a common pattern. We will see that whenever we have a composition of inverses, where the inverse is on the inside and the regular trig function's on the outside, we will get cancellation. Again, let's play it safe here. This will equal sine of, let's see, inverse sine of root 3 over 2. Angle on the right, sine root 3 over 2, that's pi over 3. Sine of pi over 3, that's root 3 over 2. Hope this helps.